Okay, so hello, my name is Popa. I am a master student at Polytechnic University of Timișoara, a second year section of advanced mechanical engineer. I'm happy to present you the paper Influence of Thickness on the IZOD Impact Strength of FDM Printed Specimen for PLA and PETG, realized together with my colleague Mihai-Petru, with Mr. Sergiu Galațanu and Mr. Professor Liviu Marșavina. Okay, I will start with a short introduction with fused deposit modeling. Next, I will present the test specimen fabrication with experiment process. After the main results and some conclusions and discussions. Fused deposit modeling, FDM, also known as fused filament fabrication, is an additive manufacturing process that follows with the carry of material extrusion. In FDM, an object is built by selectively deposit melt material in a pretension part, layer by layer. The material used are thermoplastic polymers, which came in a filament form. Advantages: mass customization, reduce tool cost, reduce the delivery, reduce the material waste by topology optimization. The material properties, both for static and dynamic loaded, are depend on process parameter, and the datasheet value are include or do not contain critical parameters like infill percentage of part orientation. The following of this paper is the objective of this paper is the following: to experimentally determination the effect of specimen thickness under impact loading, to compare the results between the PLA and the PETG materials. Test specimen fabrication. Test the IZOD specimen have been considered in according with the ISO 180 standard. 3 thicknesses size were printed with 6 specimens for each of 2 PLA and PETG. The striking distance is 22 millimeter at the top of the notch. The dimension of the specimen are shown in the table. The length of 80 millimeter and the 3 thickness dimensions of 6, 8, and 10 millimeter. Most FDM systems allow for the adjustment of several process parameters. Those include the temperature of the nozzle and the build platform, the building speed, the height, the cooling fan speed, layer thickness, 0.15 millimeter, quality settings in Prusa silence program, nozzle temperature 215 degrees, and the bed temperature 60 degrees. The first layer has a temperature of 215 degrees and the remaining layers 210 degrees. Okay, the test setup. Impact strength was experimentally determined with the IZOD test using Instron system 9050 IZOD mechanical, equipped with 1 kilogram approximately hammer that impacts the samples at a velocity of 3.46 meter per second. The specimen is clamped in the device. It is fixed by means to guide, and the hammer is diving out of an angle of 150 degree. The hammer is released and strike the upper part of the specimen. That's here in this figure. Okay, impactor parameter. potential energy 5.5 joule, impact speed 3.46 meter per second, start angle 150 degree, impactor arm length 326.8 millimeter. Okay, result. In figure are the graph of the three thicknesses for impact force versus deflection. The black curves are for the PLA materials and the orange ones are for PETG. In figure B are the graph of three thicknesses for energy versus deflection. As for the impact force versus deflection curves, we have the same color for PLA and PETG. You can see here. Okay. In the graph above shown the most specific material curves in case of impact. One curve is choose for each material thickness. In the ISO 180 standard, with which the IZOD tests were carried out, the samples are defined as having a thickness of 4 millimeter. We also carry out the test with a thickness of 4 millimeter. Yes?
2 minutes.
Oh, okay, I carry out. Okay, so unfortunately we have the hammer is too heavy for this thickness, and we could not record the energy and the force impact. Okay, in the figure A, we have here the force for all thicknesses. In figure B, we have the energy for all thicknesses and materials. And the figure C is the average of impact strength for each thicknesses and materials. What can be seen in that graph is that the impact energy is for 6 millimeter thickness is higher for PETG, even though the force is higher for PLA. Conclusion, for PLA at small sizes, the impact energy is lower than for PETG, but for thickness greater than 6 millimeter for energy increase for PLA. The increase is linear for both energies. All samples experiments are brittle fracture. The crack propagation both show a relation between sample thickness and impact force and energy. Thanks for your attention.